Hello, welcome back to our Java Object-Oriented Programming and Data Structure lectures. Uh, Last lecture, we discussed of the concepts regarding inheritance and polymorphism. So in this lecture, we are going to take a look this chapter's example. And so this chapter is chapter 5, okay? And the chapter example is Java inheritance example 1 animal. Okay, so let's take a look about this example. And the major concept in this chapter is about inheritance and polymorphism. And if you recall, inheritance is also defined as is a relationship. Okay. And in this example, we have 4 files and 3 classes. And if you recall, in our concept part, we also gave the UML diagram regarding the 3 classes. So we have animal class. And animal is a superclass. Okay. And under it, we have 2 subclass, pet and wildlife. Okay, so first let's take a look at the animal class. Okay, and in the inheritance relationship, so some of the features from the superclass will be inherited by subclass. And in order to achieve this, if you recall, we use the keyword for accessibility or visibility is protected. Okay, so let's take a look. So here we have this superclass animal. So the same thing as the previous definition for class, which is public class and class name. And if we take a look, we have instance variable, name, weight, height, maximum speed. So those are instance variables. But if we take a look, their accessibility, they are protected. Okay, so here we define them as protected. That means the 2 subclass, pet and animal, will also be able to access them. Okay, so it means that they will also be accessed. They will also be allowed to be accessed by subclass. And this count is a class variable. And it's private. Okay, so it's not inherited. Okay, and then here we have that constructor without parameters, so the default one. So just initialize the instance variable with default values and increment the count by 1 because this class variable is used to keep track of how many animals created. And over here we have 2 constructor. This is the second constructor with parameter. Okay, and the parameter type match the instance variables type. And so we are going to initialize the instance variables with the parameters. So here we didn't do the fully precondition check. Okay, so we just go ahead, direct assign the values. But in constructor, the best practice is to do the check of the parameter to see if they are in the legal range. And then because of those instance variable, and we also give the accessors or the get functions. Okay, so they are all retrieve values. The respective instance variables values, the return type match the instance variable. And here, because all of this are primitive type or immutable type, so we don't need to worry about the aliasing problem. And this get count, and this is a class method. So it's shared by all of the instance, okay? And we also have the respective mutators or the set functions. So they are pretty straightforward, okay? Get set function, and then over here we also define a kind of like a general function, utility function for animal class is to define the eat, okay, and it will output, okay, eat and so how much I eat, okay, the animal. And here we also have a function called get clone. So this is try to create a deep copy create a deep copy of the animal object. Okay. And on heap, okay, so that if you take a look here, it called new, is it? So it invoke the constructor, with parameter. And it return it, so the type match, okay. And the next comes to the toString method. For the toString, if you take a look, we have the at override annotation, okay? And the toString, why here we override? Override, generally speaking, it's one way is to override some functions in superclass. So over here, it override who? The animal is the superclass in our inheritance map. But if you recall, the root class of Java is object. That's a root class. So it's a super class of all of the class. Okay. Even though we didn't explicitly do the extend, okay, but it is. And the toString is from this object. So that's why over here, because you want animal has its own version of toString instead of just output the heap address. So that's why here you provide this override, okay. And then it's just do some output and formatting. And the last method in this animal class is the equals. And if you take it, it's also override. So override from who? From objects class. Okay. And the parameter type is object. Okay. So for the equals, so you check if the object exists. If it exists, and then you need to make sure it is the type is also animal. Is it? So here we check if it is an instance of animal. Okay, and later on we will learn. After we learn the inheritance and the polymorphism, we will see this is not the safe way. Okay, the other safe way, we use another called get class. And then we need to cast it, okay? Cast it to the animal and assign it to another aliasing variable. And then you can either do structure equality check or do for primitive data type, you can just use equal to check. Okay, so this is the superclass, animal class. Okay, the first class. And then we have the second class defined, pet. So pet is a subclass of animal. So how do we know that? Because here we have this keyword extends and animal. So that means it's a subclass of animal class. And over here, we have the two instance variable, and their type are private, not type, their accessibility. Okay, and the pet class also has a class variable to count how many pets are created. Okay, and then we start with constructor. So pet constructor, if you take a look inside, the first statement is called super. So this super is what? Okay, so this super is invoking superclasses constructor. The respective one. Okay, so this is a default superclass. So basically that's animal. And because if you recall in the animal, it has like the name, weight, height, etc. Is it? Those are animals. Animals, okay, and they are protected. So they inherited by pet class. So pet class, there is no necessity for pet class to declare those instance variable because already inherit. Those attributes already inherit. Is it? So because inherit and then when you create a pet object, you are supposed to also initiate those instance variables because those instance actually also owned by pet object. So we don't need to reinvent from the wheel. So you just call superclass is constructor. So to do that, you just write super. So this super keyword means the superclass. And if you have this printed, then that means you are invoking the constructor. And then next you initiate the pet class's own instance variable, okay? And here you also keep track of the number of pet created through class variable. This variable is shared. So class variable shared by all objects of pet class. Okay. And the pet, the second constructor is the constructor with the parameter, okay, list of parameter. So similarly, to first invoke the corresponding constructor from its superclass, from animal. So here it calls the animals constructor with parameter. And here it's initially its own instance variables and class variables. And then we have the respective accessors to retrieve the value of instance variable. And then we also have a set a mutator for the owner, okay? And if you take a look here, pet has its own eat behavior, okay? And because this eat behavior already defined in the animal, but you want subclass has its own. So that's why here you need to have this keyword, the not the annotation override annotation. Okay, the add override annotation. So keep this in mind. Okay, so the method in subclass has the exact same name, parameters, and the return type. Okay, from superclass. And this need to have that annotation at override before the method header. Okay, keep this in mind. So that that indicator has its own version. So its own behavior. And then we can also define the toString, define our own version, okay? And similar for the echo method. We are going to override animals here. So because this is for pet class, so you need to cast it to pet, okay? Then do further check. And the last method, this is for knowledge check, okay? So you can go ahead and to try it after the lecture when you study it. Okay, the third class that in this example is a wildlife. So this is a peer class as a pet, okay? Same thing, it's a subclass of animals, so you need to have this keyword extends. And then it's define its own instance variable about the habitat and ID. And the same thing, it also has a class variable to keep track of how many wildlife animal is created. And then we have its default constructor. Same thing, the very first thing you do is invoke a superclass's constructor, the respective constructor. And then we have the explicit value constructor. And before you go ahead to initialize the value of wildlife instance variable, you need to invoke a superclass's constructor, okay, and provide the respective value for its instance variable. And then we have the accessors. And we have the class method to retrieve the number of wildlife. And we also have set functions. And the same thing, we need to override the eat method for animal class. And here we also provide our own version of the toString. Okay, so we override animals. And we also override animals' structure equalities comparison. Okay, the equals. Okay, so that's regarding wildlife. So not too much new things. Okay, it's just the keyword extend, keep that in mind, and the protected defined in superclass. And also in subclass, you need to have the extend keyword to indicate from which superclass. And also, if you need to override, you have your own version of the behavior from superclass, you need to provide the overridden method, okay? And also in constructor of subclass, don't forget to call superclasses constructor. Okay, and then let's see. So this is a driver to test our the three classes that we designed. Okay, so first we create a hippo animal. Okay, so you just invoke the hippo animals, the constructor with the parameter. Then animals toString will be invoked. Okay. And then what it did is, and also keep in mind this animal, so hippo, will always keep that hippo, so here is stack. So this is a hippo, okay? And here is the heap memory, and here you have that hippo and 1500, etc. Is it? And then hippo point to here. And if you recall, in the concept parts, we also learned the concept of static type. So basically here, animal hippo, this is static type, okay? So hippo variable, the type is animal, and this is defined. Basically, this is defined at compilation time. And when you have this new animal, is it? So this is the right side, and this is, we call it dynamic class. Okay, and then you bind it, is it, with the hippo? So this is called dynamic binding. And if you recall those key concepts, okay, so this is dynamic class. So it will check, okay, the static type matches the dynamic class's type at compilation time. So it works. So it will pass. Okay. And so that's not new, okay, even from the previous chapters regarding how to create a class. But for the this static dynamic class, later on when we see the following code, we will see this is very important to keep in mind of this concept. Okay, left side, when you declare a variable, a class, object, that's static type. When you call new, okay, then that's dynamic class. Created. Why it's dynamic? Because it's created at wrong time, not compilation time, okay? And then here we have the hippo alias, and then you just directly assign to hippo. So basically that's happened is this hippo alias, it's also going to point to this uh, hippo object that's created. Okay, so this we call it a shallow copy. So hippo and hippo aliens, these two are shallow copy because they point to the same memory location on hip. Okay, so when you do this equal, and equal, if you recall from previous chapter discussion, okay, this is to check referential equality. Okay, so because this two point to the same heap memory location, yeah, so that is true. Okay, and then we call the equals. So this equals is from animal classes. Animal classes equal method. And if you recall, we have our own versions equal method in animal class, so it will invoke that. What it does, it check structure equality. Okay, not referential. Okay, and of course, because the shallow copy, then definitely this is guaranteed. Okay, and then you call the two strings. So this is animals. Okay, and then let's take a look at the running result for this first two. So the first is create an animal, so its output is it as a two string. And then here we have this hippo aliens. Then you can see, yeah, so both referential equality and structural equality are equal, and the output going to be the same as the hippo. Okay. And then next, let's see. So now what it has, this time we have the hippo clone. So what it going to call hippos.getClone method. If you recall that getClone method, we can go back to take a look at the animal class. It's a getClone. If you recall, is it has the new and return that object created. Okay, so basically what here it happens is, so we have the stack memory, and here is the heap memory. Okay, and here we have that hippo static type. Okay, and here is that hippo object. Okay, and what it does is this a hippo clone. Because it has that new, so that new will be whatever you call that new, that it will allocate a new block of memory to hold all of the information. And it get all of the values from this hippo object. So it copy the values. Okay, but at its own location, okay, with its own physical stuff. So this is hippo going to point to. So between these two, then these two, the relationship is deep copy. They have the same value, okay, for the instance variable. So when you do referential equality check, they don't point to the same. So this is false. And of course, when you do equal, then both are the same. Okay, so then it's true. And when you do the toString, yeah, the output will also be the same. And then you call animal dot get count. And over here, if you recall, it doesn't use a hippo or hippo clone, it uses animal dot get count. And why we do this? Because this get count method is class method. It's, if you recall, it has that static. Okay, so that's why you can go ahead directly use class name to access. Okay, and if you take a look like the toString, what you access is object's name. So variable, okay. Yeah, so here's a difference between object and the class. So let's clear them out. Okay, next, let's see. So now it asks you how many animals created. Is it if we take a look, we create a hippo and hippo aliens. So that's the same object. Then we have the hippo clone. So the count should be 2, okay? And then let's see, now we have this fluffers variable, is it? And it called new pet. So this is a subclass pet it create. And then it call pet class is toString. So this toString is pets, okay, not animals, okay. And this eat is also pets, okay. And this get number is also from pet. But if you take a look at eat and toString, they are the object flower, and the get number is the class name, okay? And then when we do get animal get count, how many animal we have? So the output is 2 or 3. Yeah, it should be 3. Why? Because just think about it. When you do this new pet, that within it, it also call that super. What that super is a class, is animals constructor. Animal constructor, then that animal count will be increment. So that's why animal is incremented by 1, so it should be 3, okay? And the pad, this is the first pad, so the output should be 1, okay? And we can take a look. Take a look at the running results. Yeah, here it also check referential and the structural regarding the clone, okay? And Then we have animal two is that after we create the pet, if you take a look and the animal is three, is it? And here, be careful, okay. So here we call animal that get count. So let's go back to check. So it's also three, okay, even though it's from pet class. Let's see if pet has that get. If we check, pet doesn't have get count. Pet doesn't have get count. Okay, so why you can call pets get count? Okay, so let's see the get count method. Okay. Yeah, it's because animal class has this, and it's also public, okay, has this class method get count. So that's why its a subclass can also access it, okay, because anyway, it's public, okay. And it's public and it's a subclass, so it can go ahead to use it and its count total animal is created, okay. And but if you remember for pets, its own get number, that's different. It's one, okay. And then next, let's see. So over here, then we have this variable rabbit created, okay, declared. And the fluffer, fluffers, let's go back check what is the type of fluffer. A fluffer is pet, okay. Fluffer is pet. So here, let's see. So we have the static memory stack. So we have fluffers created and the type is pet, okay. And then we have that pet created, I remember, pet object anyway. Okay, and it's point here, okay. And now we have this rabbit, but the type is animal. And you also set here to point to pet, okay. And why this is not a complaint, this is fine, because this part, okay, so rabbit, animal rabbit, this is static type at compilation time, okay? And this pet already created, is it? And this is dynamic class. And then you do dynamic binding at the runtime. You bind this pet object to rabbit static type. Okay, and why this is fine? Because pet is subclass of animal. Okay, so the relationship, it is a relationship. So pet is an animal. Okay, it is an animal. So the compile at the compilation time check, okay, then the type matches. So this is allowed. Okay, and it's dynamic binding. And then it can call animals eat method. So here, this dot it. Okay, this dot it is animals or pets. So we will see. Okay, so this it method is whose. It's pets or animals. Okay, so here it involves a concept we call it dynamic dispatch. Okay, dynamic dispatch. And if you recall, animal has a eat method and the pet also has a eat method. Okay, so basically over here, then it involves another concept called virtual table. Okay, so virtual table basically it's a very detailed UML diagram, including the inheritance. Okay, so it has animals, it also has pets. Okay, and the animal has the eat method, and the pet also has the eat method. So when this rabbit that it get called. So it will, this is its dynamic class. And through this dynamic, it will then go to the virtual table to find the respective method. It will go the furthest. The furthest along the virtual table to find the respective method. And because pet does have the eat method, so then this eat will be pet's eat method. Okay. But then can you also, because you say, okay, anyway, it's fluffer as it's a pet. So then can I also call that get owner method? Then the answer is no, because animal doesn't have the animal doesn't have that behavior, so you cannot call it. Okay, but if you do want to, because you say, okay, it's anyways a fluffer, is it? And so I do want to know the owner, then what you can do is you need to cast it. Okay, downcasting. Okay, do the downcasting. And then you can go ahead and call the get owner method. Okay, and when we do the get count for the animal, do we have new animal created? No, because this is also alias to the same object. Okay, so here we have all of this concept demonstrated in this example. Okay. So we just mentioned, so basically this is dynamic dispatch. Okay, and the eat, if you recall, animal has eat method, and then pet class also has the eat method, is it? And through override. Override annotation. Okay, and so, but the eat behaves different. The name the same, the format the same format. Basically, same header, is it? Here. exactly the same method header, but behaves different, is it? So this is a concept, we call it polymorphism. Polymorphism. Okay, so, and this polymorphism is dynamic polymorphism. Okay, it's through that override, through this override, okay, between superclass and subclass. So this dynamic polymorphism is achieved through this dynamic dispatch. Okay, the dynamic dispatch is look for the furthest method, the overridden method along virtual table chain. Okay, so that's how all of this work together. Okay, polymorphism. Okay, and this polymorphism, remember, it's a dynamic polymorphism. It's not a static. If you recall previously, we discussed that a static polymorphism is through function overload. Okay, that's different. Okay. Okay, then let's continue. There's some respective knowledge check, and you can try. Okay. And what next we showed is, and also show the polymorphism, the application. Okay, you can see it's quite nice. Okay, so here we create an animal array. We have a 5 animal array. Okay, and the first animal, we call it a fluffer clone. So it uses fluffers get clone. Okay. And fluffers get clone, if you recall fluffer, I remember fluffer is pet. That's I remember. Okay. So it's a get clone. Let's also go back to take a look if pet has its own get clone. Pet doesn't have its own get clone. Okay, so this get clone is through animals get clone method. Okay, and then the first array element point to the fluffers. So let's take a look. Okay, so this is a heap memory. So here we have that stack memory, and we have fluffers. So fluffer point to a pet object. And so animal 0 also point to fluffer. Okay, so they are aliens. And rabbit also point to, I remember, point to this fluffer. Okay, and the second array element also point to pet object, okay? And the third one, so animal 3 point to, so fluffer get clone. So clone. So you have pet object and it point to here, okay? And then we have the, oh, this is 2, this is 3. And this is a wildlife object, okay? And then we have the pet object again. Okay, so that's the memory diagram, okay? And then we go ahead to call a function called display. Then you pass in the index and the animal array. And the display function basically what it does is just go ahead to use a loop through the animal array and call the respective animals toString method. ToString method. Is it? And if you see the dynamic type, not dynamic, static type for the array is animal. Is it? And but here are the dynamic class created. And then through the dynamic binding bind with the respective reference and with uh, the respective variables, okay, variable, and the variable basic here is reference, okay. And if you recall, and then they all call the toString. The toString here, we have 3 different types. We have animals. Oh, let's go ahead to that virtual table. Virtual table. Okay, virtual table, we have object, and then we have animal, then we have pet, and also wildlife. That's it. And they all have that toString method. Okay. So when it call that toString method, it will using what? It will, so here it's dynamic polymorphism. So it will use the concept of dynamic polymorphism. Dynamic polymorphism is achieved through dynamic dispatch. Okay, so it will look for the furthest along the virtual table chain, as they look for the furthest method toString. Okay, and so it will based on their its own respective either pets or wildlife. Okay, or if it's animal, it's animals. Okay, so that's the whole idea about demonstrate the polymorphism. Polymorphism um, is you have different 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 forms. Is it even though same name but different forms shows differently the behavior. Okay, even though the name the same, so that's we call polymorphism. But here it's regarding dynamic polymorphism. Okay. So it's through that overridden method. And overridden methods along the virtual table chain go furthest class. And after that, you can also go ahead to check the respective animal created, pet created, and wildlife created. Okay. And then next is discuss is equals method. Okay. And the equals method, if you recall, should be symmetrical. Symmetric. Okay, not asymmetric. So that means if fluffer equals rabbit, then rabbit and equals fluffer. So if true, then both should be true. False should be both false. Okay. So let's see. If you recall, fluffer and rabbit, they are shallow carbon. So then definitely this will be true. Okay. So no problem. Okay. So then here we try to verify because both refer to paths. Okay. Paths is equal method. If it's implemented correctly, yeah, it's implemented. We see, okay, with this case, it's all right. And then here is a fluffer, so paths. But the fluffer's clone, if you recall, it's static type is animal. Animal. Okay. And when you do that equals check it check the object. So it will check Fluffer's clone is instance. So instance of animal. Yeah, Fluffer's clone. Yeah, even though it's if you recall the dynamic class, its dynamic class is pet, and pet is animal. The relationship is a relationship, so the instance of check will be okay. So then that means this is true. Okay. Oh, so flowers is instance. Oh, I'm sorry. This is not true. It's instance of. No, it's a subclass. Okay, so this is I got messed up. Sorry. So its dynamic class is pet, so it's not an instance of an animal. Okay. So this will be false. This will be false. And then fluff is a clone. Let's check. Uh, uh, no, this is true. Okay. Got to mess up again. So this should be true because the dynamic class is pet. Pet is animal. Okay. So this is okay. And then let's go back to check. So now Fluffer's clone is animal. Philosopher's clone static class is animal. Okay, the static type. Let's remove it. Yeah, it's easy to go get get messed up here. So let's go back check. Okay, first check this equals. Okay, so because equals it use instance of method to check the object. Okay, so Fluffer's static type. I remember Fluffer's static type uh, is also pet. Is it is pet, I believe. And dynamic also pet. Okay. And Fluffer's clone. So Fluffer's clone, it's static is animal, and dynamic is the clone. It is called animals clone. It doesn't, pet doesn't have clone, so it's also animal. Okay, also animal. And so over here, fluffers is, so it's check the instance of. Instance of. Okay, because a fluffer is a pet. So it want to check if it's instance of a pet. Okay, fluffer. I need to go back to check what's the fluffer type. The fluffer is fluffer is pet. Okay, and the fluffer's clone is animal. Okay, so then here you check is instance of. So fluffer clone. So here you want to check fluffer clone is instance of pet, and of course it's not. Is it? So this is false. This is false. Okay. And then let's check this part. So fluffer clone is animal, is it? And then you check the fluffers, fluffers. So this time, you check fluffers. And if it's animal, okay. If it's animal, is it? And so if it's animal, and the fluffer, if you recall, fluffer is pet. Yeah, static and dynamic. It's a pet, and pet is animal because it's animal subclass. Is it? So this is true. This is true. Okay, and this is true. One way is false, the other way is true. So it's not symmetric. So this is asymmetric. So that means the equals method implement has some issue here. Okay, so we need to probably go back to check. Okay, and then same thing for rabbit because rabbit anyway is the aliens of flowers. So analysis of these two are the same. Okay. So that's regarding the ecos that so far we implemented, and we did see there are some issues with the current implementation. So in Java, there is another class, not another, another method that we can check the dynamic class. So this method called get class method. So get class method will return the dynamic class. Okay, so that when you implement the equals method using this get class instead of that is instance of, okay, that will be more accurate. Okay, and if you see here object, then the get class will give you the object. Fluffers get class, it will give you pet. Animal, it will return you pet. Fluffer, because if you recall, the static one, is it the dynamic one? Because it's through the get clone. Get clone is animal, so that's why the get class, it will be animal. Animal. Okay, so all this get class will return the dynamic class. And lastly, let's just take a quick look of this display. Okay, previously we already discussed. So within the display, is it so because you see the variable type or the parameter is object, it's the root class, is it? So it just go ahead to call the root class as a toString. But if you recall in the animal array, is it use each owns the toString. So that's regarding dynamic polymorphism. Okay. Okay, so then let's go back to see the equals method. Okay, so in order to avoid that issue, is it, and if you remember, we implement using instance of to check, is it? So that's not accurate. So because this will have issue with the inheritance superclass, subclass, is it? So the accurate way to implement the equal is to use the get class, because get class will use the dynamic class to do the accurate check. Okay. Okay, so that's regarding uh, this inheritance and polymorphism example in chapter 5. Okay, so we complete our discussion for chapter 5, concept and the example. Okay, so we will discuss the further concept regarding inheritance and polymorphism in our next chapter. So see you.